Today we're going to be discussing charge tapes. The purpose of today's lab is to see how different charges interact with charges in their environment. We have two coded models, one with a point charge and one with a line of charges. The physics fundamentals for this lab is Coulomb's law, gravitational law, and electrical fields. And here are the results for our lab. The predicted results was that the point charge would have been higher than the line of charges, or that it would have been more accurate towards the math we had. As you see, these are the results of our lab. Experiment 2 is the math we gave, and then the code 1 and coded 2 is the point charge and the line of charges. And any errors we had in our code were due to human error in the code or in the math. Now, we have an experiment where we used charge tape and interacted with different objects in its environment. We used a hand, a desk, and then another charge tape. The initial conditions for this lab experiment are all the same. We have a charge tape, which is then interacts with an object and its surroundings. The system is the charge tape, and the surroundings is the object that interacts with it and the earth around it. Now, first we have a charge tape with a hand. As you can see, the hand and the charge tape is attracted to the hand, and this tells us that they have opposite signs. Now for the desk. This also tells us that the desk and the charge tape either have opposite signs or that the desk is neutral. Now here's some questions that we were asked. If a U-tape is positively charged, it should attract a negatively charged plastic pen and repel a positively charged one. If a U-tape is negatively charged, it should repel the negative charged plastic pen and attract a positively charged one. A neutral U-charge should experience a weak attraction to a charged plastic pen because of induced charges. When you rub a plastic pen on hair, it closes, it should become negatively charged. By observing the interactions, if the U-charge repels the charged plastic tape as the same negatively charged one, and if it attracts, it becomes positively charged, opposite positive charge. And based on typical lab results, the U-tape is usually negatively charged. And here's U-tape with the U-tape. As you can see, they were both repulsing one another, meaning they are the same sign throughout the experiment. And here's experiment 2, where we had two floating tapes, and then we took the gravitational pull on the tapes, and then we found the charge using that. We took the formula for Coulomb's law and replaced the force with the gravitational force because they cancel each other out. And then we solved for Q as shown in the left-hand corner. Here's our first coded model. We first initialize the initial conditions of each constant. We have the mass of the tape and then the distance of the tapes. And then we have the same way we solved for Q, replacing the force of the electrical force with gravitational force. And then below we have the R vector, the magnitude, and then the R hat, and then we solve for the electrical field. As you can show, there's the formulas in the left-hand corner, and we solved it the same way we did before. And here's the models. As you can see, we had some slight error because all the arrows did not show, but that is the charge. This is the model for the point charge particle. As you see, here's this code. You see we have the line of charges, which should give a more accurate result. And first, we found Q. We have the initial conditions, the initialized code, and then we have the charge we found, and then we have the electrical field, and then we have the line of charges. And that's the result we got with this code. Here's our model for this. As you can see, it worked, and we did not have any errors with this model. And the similarities and differences. As you can see, we had a point charge versus a line of charges, which would be more accurate in the results. And you can see the charges were. We have the charge on the left being the point charge, and the charge on the right being the line of charges. Now, what if? We are asked, what if the charges for a positive electron become negative, and a negative electron become positive, and a proton become negative? What would happen? Nothing would change because each charge would change and they would still interact the same way with one another. Now, what does it mean? We are asked which one is more accurate, a point charge or the line of charges? And the line of charges is more accurate because the point charge model simplifies the tape into a single charge particle, while the line of charges model accounts for the charge distribution along the tape. And this makes it more accurate, more closer to reality. And we performed this experiment to see how certain charges interact with one another. And the results are that opposites certainly attract one another while like charges repulse. As you learn, we also learned how to calculate the charges using tape in the environment around us. The errors that occurred during this were human error in the math or code, and the aspects of the environment that could not be accounted for in the math.